The next session is going to talk about UV perturbation. So in the previous session we showed and demonstrated that the texture projection lookup shader, which can be found under texture space generator projection, is designed to extract these UV information onto the object. In this case I'm going to use a map lookup to look up an image, and I'll connect it directly to the coordinate port and connect it to the surface. So if I draw render region, I get this this projection because the actual grid had already an XZ projection being applied to it. In this case, let's now apply a little bit advanced textures or UV perturbation effect. So the kaleidoscope shader is designed to create this. Well, the name says it. It's to create this kaleidoscope effect here. So you can actually start to rotate and get this pattern like to be repeat. The actual interesting aspect of this UV perturbation is that you can actually stack them up and use other shaders. So depending the order it is being applied, you can actually get pretty interesting effect. So for example, if we put the actual warp, so let's connect this right here. The texture coordinate is actually designed for the actual UV to be perturbed, and the noise coordinate is used as some sort of a seed to actually perturb the UVs. So I'm going to connect this one to chord. So now I'm perturbing the kaleidoscope effect. So that's pretty neat. You can also animate this through time, for example. So something like this. So I can go from no perturbation to very intense perturbation, like this, for example. That is very handy effects. Also, you can actually inverse the actual connections here by doing this. And let's connect this one here to here, and connect this one right here to chord. So let's go back to. So what we do actually here is that it creates a perturb UV which gets the actual kaleidoscope applied. So the other one was a little bit more and had a little bit more interesting effect. Now let's just keep the actual 3D warp here, and let's put it to, let's say, one like this. Voila. What is quite interesting is that you could use other procedural shaders to actually perturb other textures. Let's say, for example, you have texture generator. The difference between textures here is that these shaders are designed to look up their own UVs onto the object. So there's no way actually to insert any shader to modify the UVs or anything like this. It's kind of a closed shader that will look up its UVs, take this UVs and give it to procedural node, which is cell, cloud, or fractal, and that shader will return the actual result from that UV position. The texture generator here are shader that don't look up any UVs. They are expecting UVs to be given to them, and that is really an interesting effect, because with this you'll be able to actually start to create very advanced effects. So let's connect the actual texture projection lookup to the coordinate here. So if we connect this one directly to the surface, now we get a terrain shader. So this is pretty much the same thing as going and getting this shader here, except that we do have access to this coordinate being extracted by this shader to be able to apply it to other effects. I'll go to terrain here and adjust to have some sort of black and white effect here, and I'm going to connect this one to the noise texture. So automatically XSI, or the render tree tool, will be doing an insert of a conversion shader. In this case, it's going to map the RGB to XYZ. and then we can connect the actual image to the surface. Now what we do is we can use a terrain generation to actually start to dissolve a texture. So and we can actually start to animate this. So we can say 0, then we get no texture, and then suddenly we get, let's say, all together at the same time, we get the actual effect to get the dissolve effect as you want. So that's kind of a neat technique for getting objects to disappear. Let's say a la Star Trek or something like that, some sort of space opera. So that is the actual possible techniques to actually do the warping. There's you can actually start to do some sort of edit. For example, edit is a little bit more like a kind of a manipulation or manipulator effect. So let's say, for example, we connect this one to input, and we connect this one directly to the actual coordinate right here. Now what we have, I'm going to refresh and just get the actual texture to show up. So if I do this, for example, now we have this option where we can say, okay, I want to have 2 repeats on X or Y, and I want to do, let's say, alternate to do some sort of flip-flop, and for example, whenever the actual let's say I do, this is an offset, for example, then if there's an offset you can actually start to do some warping. So let's go 0, let's put back to 1 1, and let's remove this information right here. And if we do a small offset 0.1, then I'm doing an offset. So this is the same thing as I did in previous lessons, where I went and used the vector to do an additive, to add basically values to the U, V, or the W. So the offset here is basically the same thing. So the range here is some kind of a scaling factor. So if it's basically kind of a re-range or a change range. So you should see this. So if you want to crop out part of the image, for example, then you could start to do this. So for example, if you want to repeat a cropped section, for example, that's how you would use this thing here. So let's say if you want to say 0.5, 0.5, and you say, for example, 1, 1, then you're just cropping a different section. The interesting thing about this is that it's not actually cropping the pixels in the image, but it's simply using a portion of the image at render time. If you are using this technique with a very large texture, for example, keep in mind that the entire image will be loaded in memory, even though there's only a portion being used here. So that is something that is important to understand. So let's go back to 1.1 here. The other control that is interesting is this texture SRT. Texture projections. There's really 2 types of texture projection. There's planar type, and then there's 3D type. The planar type is more like a planar projection, spherical, cylindrical, lollipop, where 3D projection types will be more like spatial texture projection, where the U, the V, and the W is being used. W being the depth in this case. So there's really 3 components. So if you do apply SRTs to the UVs, then depending on the axis you'll get some sort of effect. In this case, what I want to do is start to rotate things in 45 degrees. So in this case, the x-axis is more towards this line here. So this is not what we want to do. Let's do 45 degrees here. No, that's not the axis. Z is the axis here. So it's going to rotate around the corner, not the center. So you can actually start to animate these parameters to be able to do some sort of effect here. Same thing for scaling. So you could do pretty much the same thing here. So let's say you do 2.2. This is and you make it 0.1, 0.1. You're pretty much doing the double work here, but I just want to explain that you could do the scaling here, or you could do the cropping here, depending on how you need to do it. So let's just put it back the way it was here, and you can actually start to add some translation here. Same thing, which is basically the same thing. The reason why this is available right now is that you can actually have some of the effects are being computed before or after some of the mats. So the actual every of these particular control here are applied in an order. So depending on what you want to achieve, you may want to actually drive the actual offset here or here. So this is just want to let you know how and what components are being used here. So if I do 0.5 here and I do wrap, then obviously whenever the actual image is being will basically exceed the 0,1 range, which is what the UV value valid range are, then you could say no, do a wraparound. So go back to the 0,1 whenever you exceed 1. So you can actually do these type of thing here. Voila.